Write in the missing numbers. First, 45 plus something equals 110. So whenever we have a missing number addition problem, we can always use subtraction to find our missing number. So we need to work out 110 minus 45. To do that, we can use column subtraction, and that gives us our answer 65. Now, 4 times 5 minus something equals 12. So here we have brackets, and we always do what's in brackets first. So 4 times 5 is 20, and now we need to think 20 minus what is 12? Well, 20 minus 8 is 12, because 20 minus 12 is 8. So our missing number here is 8. And finally, we have 60 times 3. That's 180, because 6 times 3 is 18, and then if we have an end zero in a multiplication question, we need an end zero in our answer. Write these amounts of money in order of size, starting with the smallest amount. So we have £5.40, £0.65, so that's the same as 65 pence. Then we have 72 pence, which could be written as £0.72. Then £10, and we could write that as £10 with a .00 on the end to show that we don't have any extra pence in £10. And we have £2.88. So the smallest amount is £0.65, or the same as 65 pence. Then we have £0.72, so that's 72 pence. Then £2.88, then £5.40, and our largest amount is £10. This table shows the increase in bus fares. Sohan's new bus fare is 72 pence. How much has his bus fare gone up? So we know that his new fare is 72 pence, which we can see here, and if we look across, we know that his old fare would have been 60 pence. But the question doesn't ask what was his old fare. The question asks how much has his bus fare gone up. So how much more is 72 pence than 60 pence? So here, because we're finding the difference, we need to use subtraction, and 72 minus 60 is 12. So that means his fare has gone up by 12 pence, because 72 pence is 12 pence more than 60 pence. Now, Millie says my bus fare has gone up by 10 pence. How much is Millie's new bus fare? So we need to look at the old fare and the new fare and find a difference of 10 pence. And we can see that 75 pence plus 10 pence is 85 pence. So that means that Millie's new bus fare, her new fare, will be 85 pence. Her old fare was 75 pence, but it's gone up by 10 pence, so it is now 85 pence. Draw the reflection of the shaded shape in the mirror line. So to reflect a shape, we need to count squares. So if we look at this square here, from the mirror line, we go across one square and then shade. So to reflect it in the other direction, we can go across one square and then shade. For this square here, from the mirror line, we go across half a square, across another square, and then shade. So in the other direction, we can go across half a square, across another square, and then shade. For this square here, we go across a square and then shade. So from the mirror line, we go across a square and then shade. And finally, this square here, we go across half a square, across another square, and then shade. So we go across half a square, across another square, and then shade. So we've reflected the shape in the mirror line, because we have the same on both sides and each shaded square is the same distance from the mirror line on both sides. Circle the number nearest to 1000. So first we have 1060. That's 60 more than 1000. 1049 is 49 more, and 1100 is 100 more. Now 960 is 40 less. If we subtract 960 from 1000, we'll get 40, or from 960 we would need to add 40 to get to 1000. And 899 is 101 less. We could add 101 to 899 to make 1000. Now, because we want the number nearest, it doesn't matter whether the number is less or more than 1000. We want the number with the smallest difference. So 960 is the number nearest to 1000 because it only has a difference of 40, and all of our other numbers have a difference of more than 40. Draw two more straight lines to make a rectangle. So we can imagine that this point here and this point here will be two of the corners of the rectangle. And to get from this point to this point, we can go across one and up two. So now, if we take this point here and go across one and up two, we can see that the other vertex, the other corner of our rectangle will be here. So then all we need to do is join up our corners. And we have a rectangle because we have four right angles and opposite sides are the same length. Or what we could do is just turn our page, and I find this easier because then it's much easier to see how the rectangle will be formed. Lewis makes a call from a telephone box. He has £2 in coins. He uses these 5 coins to make the call. How much money has he got left from the £2? So first, we need to work out what the call costs. So work out the total value of these 5 coins. 50 plus 20 is 70, plus 20 is 90, plus 10 is 100, plus another 10 is 110. So he's used 110 pence, which is the same as £1.10. So he started with £2 and spent £1.10. So we can subtract what he spent from what he started with to find what he has left. £2 can be written as 2.00, and if we subtract £1.10, that gives us £0.90 or 90 pence. So with the £2, he spent £1.10 and has 90 pence left. Put a tick in each row to complete this table. One has been done for you. So they've told us that 0.9 is greater than 1/2. And that makes sense because the first digit after the decimal point tells us how many tenths we have, and 9/10 is greater than 1/2 because 1/2 is the same as 5/10 or 0.5. Now we have 0.06. So we need to remember that the second digit after the decimal point is our hundredths digit. So here we have 6/100ths. Now we need to compare that to 1/2. So we need to think 1/2 is the same as how many hundredths? Well, we can find an equivalent fraction, and 1/2 is the same as 50/100ths. So because 6/100ths is less than 50/100ths, that's less than 1/2. Now 11/20ths. We need to think 1/2 is the same as how many 20ths? 2 times 10 is 20 and 1 times 10 is 10. So because 1/2 is the same as 10/20ths, 11/20ths is greater than 1/2. And now we have 0.21. So that's 21 hundredths, because the second digit tells us how many hundredths we have. So if we have 2 digits after the decimal point, our denominator will be 100. But 1/2 is the same as 50 hundredths. So 0.21 or 21 hundredths is less than 1/2. Write in the missing digits to make this correct. So we have a missing digit column multiplication, and we solve this by following the same steps that we use for column multiplication, so starting by multiplying our ones digit. We have something times 6, and we have a 2 as the ones digit of our answer. So how can we make a ones digit of 2 if we multiply by 6? Well, we could have 2 times 6 is 12, or we could have 7 times 6 is 42, because they both end in a 2, so we'll give a ones digit in our answer of 2. So let's try 2 times 6. That's 12, so 1, 2. And if we move on to our tens column, we have 4 times 6, which is 24. And if we add the 1 on top, we get 25, so 2, 5. Now, we can be confident that this digit must be a 2, because we have 25 when we multiply 4 by 6 and add 1, and we have 5 as the tens digit of our answer. So now, onto our hundreds digit, we have something times 6 plus 2, and we have a 20 in our answer. So what times 6 plus 2 is 20? Well, before we added 2, we would have got 18, because 18 plus 2 is 20, and 3 times 6 is 18, so that means 3 times 6 plus 2 gives 20. So this missing digit here is a 3. 342 times 6 is 2052. This was the time on Celine's watch when she set off for a walk. What time did the watch show 20 minutes before this? Well, first let's work out the time that the watch shows now. We can see that the shorthand, the hour hand, has gone past 10, so the number of hours is 10, and the minute hand is on the 3, and we multiply the minute hand number by 5, so 3 times 5 is 15. So the time on the watch is 10:15. But we want the time 20 minutes before this. So on a timeline, we can write 10:15, and we need to subtract 20 minutes. First, we can subtract the 15 minutes that we have, and that will take us back to 10 o'clock. But that's subtracting 15 minutes, and we want to subtract 20. So we need to subtract another 5 minutes, because if we subtract 15 and then 5, that's 20 altogether. So we have 5 minutes before 10 o'clock. Remember, there are 60 minutes in an hour, and 60 minus 5 is 55. So the time would have been 9:55. What time did it show an hour and a half after she set off for the walk? So we need the time that's an hour and a half after 10:15. We can add 1 hour to 10:15 to take us to 11:15, but then we need to add another half hour. So half an hour is the same as 30 minutes, because 1 hour is 60 minutes and half of 60 is 30. So if we add 30 minutes to 11:15, that will take us to 11:45. So that's the time an hour and a half after she set off for the walk. And if it's easier, we could draw a timeline like we did up here to solve this part of the question as well. We could count on an hour to get to 11:15 and then count on another 30 minutes to get to 11:45. Calculate 847 divided by 7. So we can set this out as a short division. 8 divided by 7 is 1 remainder 1, because 1 times 7 is 7, and then we need one more to get to 8. 14 divided by 7 is 2, and 7 divided by 7 is 1. So our answer is 121. Here is a diagram for sorting numbers. Write these 3 numbers in the correct boxes. You may not need to use all of the boxes. So we have the numbers 9, 17 and 20. So let's start with the number 9. First, we need to decide whether it's prime or not prime. So we need to remember that a prime number only has 2 factors. A prime number is only in the 1 times table and its own times table. But 9 is not a prime number because it's in the 3 times table as well. The factors of 9 are not just 1 and 9, but 3 as well. So it's not prime, which means we now need to decide whether it's even or not even. An even number is a multiple of 2, so a number that ends in 0, 2, 4, 6 or 8. So 9 is not even, which means we can write 9 in this box here. Now let's work out where we can write the number 17. 17 is a prime number because it's only in the 1 and 17 times tables. It only has these 2 factors. It doesn't have any other factors. So 17 is a prime number. And 17 is not even because even numbers end in 0, 2, 4, 6 or 8. So 17 is an odd number. So 17 can be written in this box here. And finally, we have the number 20. That's not a prime number because as well as 1 and 20, 20 is also in the 2, 4, 5 and 10 times tables. But 20 is an even number. It's a multiple of 2, and we know that because it ends in a 0. So 20 goes in this box here. This shape is 3/4 of a circle. How many degrees is angle X? So here we need to remember that angles around a point add up to 360 degrees, or that a whole turn is 360 degrees. So because it's 3/4 of a circle, we need to find 3/4 of 360. That's 270, because 360 divided by 4 is 90, times 3 is 270. So that's the size of angle X. The other way would be to spot that if angle X is 3/4 of a turn, we have 1/4 of a turn here, and 1/4 of a turn is 90 degrees. So if we subtract 90 degrees from 360, because 360 is the total of angles around a point, again we get 270. Book sale. Any 3 books for £14.50. Lee bought these 3 books in the sale for £14.50. How much money did he save altogether compared to the full price of the books? So what we need to do is work out the total cost of the 3 books if they're not in the sale, and then find the difference, so subtract £14.50 to find how much money he saved. So we can work out £3.99 plus £5.99 plus £6.99. Now we could use column addition for this, but because we have prices which are only 1 pence less than the next pound, what we can do is round up. So £3.99 is just 1 pence less than £4, £5.99 1 pence less than £6, and £6.99 1 pence less than £7, and 4 plus 6 plus 7 is 17. So that's £17, but because the prices were 1 pence less for 3 things, we need to subtract 3 pence from £17. So £17 minus 3 pence is £16.97. So we know that the books would have cost £16.97 if they were not in the sale. But in the sale, they were £14.50. So to find how much money did he save, we need to find the difference, and we do that using subtraction. So if we use column subtraction, that gives us £2.47. £16.97 is £2.47 more than £14.50. Here are two spinners, A and B. Each one is a regular hexagon. For each statement, put a tick if it is true. First, scoring 1 is more likely on A than on B. So if we look at spinner A, we can see that the number 1 covers 3 out of the 6 pieces. So that's 3/6 or 1/2 of the spinner covered in ones. But on spinner B, we can see that we don't have half, we have 1/3 of the spinner. So that means scoring 1 is more likely on A because 1/2 is more than 1/3. Now, scoring 2 is more likely on A than on B. So on spinner A, we can see that the number 2 covers 2 of our 6 pieces. So that's 2/6, which is the same as 1/3. And on spinner B, again, we have 1/3 covering number 2. So the chance is 1/3 on both spinner A and on spinner B. So this statement is not true. It's equally likely to score a 2 on spinner A and on spinner B. Now, scoring 3 is as equally likely on A as on B. So on spinner A, we can see that 3 is 1 out of our 6 sections, but on spinner B, it's 1 out of our 3 sections. So this statement is false as well. It's less likely on A, because the chance of the spinner landing on the number 3 for spinner A is only 1/6, but for B, it's 1/3, and 1/3 is larger than 1/6. Now, Zara spins both spinners. The score on A is added to the score on B. She says the sum of the scores on both spinners is certain to be less than 7. Is she correct? Explain how you know. So the sum is what we get when we add, and we can see that she must be correct, because 3 is the highest score on both spinners, and 3 plus 3 is 6, which is less than 7. So that means when you add the scores on both spinners, it is certain to be less than 7. Calculate 1025 minus 336. So we can set this out as a column subtraction, making sure that we have the digits lined up on the right-hand side. Now we can't do 5 minus 6, so we go to the left, 1 less, 1 in front. 15 minus 6 is 9. We can't do 1 minus 3, but when we go to the left, we have a 0. So we need to go to the left again, 1 less, 1 in front, and now 1 less than 10 is 9, 1 in front, so we have 11 minus 3, which is 8. 9 minus 3 is 6, and 0 minus nothing is 0. So we get 689. Measure accurately the longest side of this shape. Give your answer in millimeters. So the longest side will be this side here, and what we can do is line up our ruler so that we have the 0 point on the ruler lined up with the end of the line. And then we look to the other end of the line and we can see that it's 10 and then 2 more of these little lines. So that's 10.2 centimeters or 10 centimeters and 2 millimeters. But we need to give our answer in millimeters. So we need to change 10.2 centimeters into millimeters. To do that, we multiply by 10, and 10.2 times 10 is 102. So the length of this line is 102 millimeters. And for this question, 101 millimeters and 103 millimeters will also get you the mark. Now measure accurately the smallest angle in the shape. Use a protractor angle measurer. So the smallest angle will be this angle here. So what we can do is line up our protractor so that we have the cross on the protractor on top of the angle, on top of the point of the angle, and then it's lined up so that we have the 0 point on the protractor in line with one of the lines on our angle. So now, because we're using the outside scale, we have 20 and then another 2 little lines, so that's 22 degrees. And here, 21 degrees and 23 degrees will also get you the mark. Calculate 509 times 24. 9 times 4 is 36, so 3, 6. 0 times 4 is 0, plus 3 is 3, and 5 times 4 is 20. Now we can cross out our working and write a 0 on our second answer line. 9 times 2 is 18, so that's 1, 8. 0 times 2 is 0, plus 1 is 1, and 5 times 2 is 10. So if we add up our answer lines, 6 plus 0 is 6, 3 plus 8 is 11, so 1, 1, 1 plus 0 plus 1 is 2, 2 plus 0 is 2, and nothing plus 1 is 1. So our answer is 12,216. Complete these fractions to make each equivalent to 3/5. So first we have a fraction with a denominator of 10. To find equivalent fractions, we can use multiplication. So 5 times 2 is 10, and if we do the same to the numerator, 3 times 2 is 6. So that tells us that 3/5 is equivalent to 6/10. Now this time we don't know the denominator, but we do know that the numerator is 12. So we can think 3 times what is 12? Well, 3 times 4 is 12, and this time we need to do the same to the denominator. So multiply the denominator by 4 as well. And 5 times 4 is 20, so that gives us our missing denominator. And now we have a denominator of 15. 5 times 3 is 15, and 3 times 3 is 9. So that's our missing numerator here. A is the point 1060, B is the point 2020. M is the midpoint of line AB, so that's right in the middle. Write the coordinates of M. So we know that point A has an x-coordinate of 10, and point B has an x-coordinate of 20. So because M is the midpoint, we need an x-coordinate that's right in the middle of 10 and 20. So the number in the middle of 10 and 20 is 15, because then we have 5 on each side. So the x-coordinate of M is 15. And now the y-coordinate, so the second number of A, is 60, and the y-coordinate of B is 20. Again, if M is the midpoint, then we need a coordinate that's right in the middle of 20 and 60. So that's 40, because then we have 20 on each side. So the y-coordinate of M is 40. Now C is on the x-axis, directly below B. Write the coordinates of C. So because B has an x-coordinate of 20, point C will have an x-coordinate of 20 as well. And because C is on the x-axis, that means the y-coordinate will be 0. triangle ABC is isosceles and has a perimeter of 20 centimeters. Sides AB and AC are each twice as long as BC. Calculate the length of side BC. So we know that the triangle is isosceles, which means that these two sides are the same length. And we know that these sides AB and AC, are twice as long as BC. So we need to calculate the length, and we know that the perimeter is 20. So remember, the perimeter is the total length around the outside of a shape. So with a bar model, we can draw one bar for BC, and then we can use two squares for lines AB and lines AC, because lines AB and AC are twice as long as BC. Now the total length, the perimeter, is 20, and because we have 5 squares, if we divide the total, divide 20 by 5, that tells us that each square is worth 4 centimeters. So line BC is 4 centimeters, and our other lines AB and AC are both 8 centimeters, because they have 2 bars of 4, and 4 plus 4 is 8. So the side BC is 4 centimeters long. This chart shows the amount of money spent in a toy shop in 3 months. How much more money was spent in the shop in December than in November? So we have a bar chart, and we need to know what each of these lines represents. So to get from 0 to £10,000, we have 1, 2, 3, 4 lines, and if we divide 10,000 by 4, we get 2,500. You're probably spotting the pattern that 100 divided by 4 is 25, 1,000 divided by 4 is 250, so 10,000 divided by 4 is 2,500. So we need to work out how much was spent in December and November. If we go to the end of our bar for December, we can see that that's one line after £30,000, so that's £32,500, because remember, each line is 2,500. And then if we go to the end of our November bar and draw a line down, that's 2 lines after 10,000. So we'll have 12,500 and then £15,000. You can see 15,000 right in the middle of 10,000 and 20,000. Now the question asks how much more, so we need to compare these two values. We need to find the difference, and we do that using subtraction. So when we use column subtraction, we get £17,500. So that's how much more was spent in December than in November. Here is a sequence of patterns made from squares and circles. The sequence continues in the same way. Calculate how many squares there will be in the pattern which has 25 circles. So if we look at the number of circles, we can see that we have 2 more each time. So that means to find the number of circles from the number of squares, we must multiply by 2 and then add 1. Because 1 times 2 is 2, but 3 is 1 more than that. 2 times 2 is 4, and then we need to add 1 to make 5. And 3 times 2 is 6, plus 1 is 7. So we know that we need 25 circles. So what times 2 plus 1 is 25? Well, if we work backwards, we can subtract 1 to get 24, and then divide by 2 to get 12. So that means if we have 12 squares, we'll have 25 circles. 12 times 2 is 24, plus 1 is 25. So that's 12 squares. Now for this question, we could just continue the sequence. So we can see that the number of squares is going up by 1 each time, and the number of circles going up by 2. So we could continue the pattern, and then we'd see that if we have 12 squares, we have 25 circles. Calculate 15% of 460. So remember, a percentage is a fraction with a denominator of 100. And to find a fraction of a number, we can first divide by the denominator and then multiply by the numerator. So we can work out 460 divided by 100 and then multiply our answer by 15. So 460 divided by 100 is 4.6. Remember, we really have an invisible decimal point on the end of a whole number, and we can copy that down and then move the digits 2 squares to the right, because we're dividing by 100, which has 2 zeros. But we can ignore zeros on the end of decimals, so our answer is 4.6. So now we need to times top to multiply by the numerator and work out 4.6 times 15. Remember, if we have a decimal point in a multiplication question, we need to copy the decimal point down into our answer. 6 times 5 is 30, so 3 0. 4 times 5 is 20, plus 3 is 23. We can cross out our working, write a 0 in our second answer line. Now 6 times 1 is 6, 4 times 1 is 4, and if we add up our answer lines, we get 69.0 or 69 as our answer. We could have also solved this question in a different way. So we can find 10% of a number by dividing by 10. So 460 divided by 10 is 46. But that's 10%, and we need to find 15%. So we need another 5%. 5% will be half of 10%. So half of 46 is 23. And then we can add those together to get 15%. 46 plus 23 is 69, so we get the same answer. This is a centimetre grid. Draw 3 more lines to make a parallelogram with an area of 10 centimetres squared. So to find the area of a parallelogram, we multiply the base by the height. And we can see with the line that they've drawn for us that the height is 2. So we need to think, what times 2 is 10? Well, 5 times 2 is 10, so that means the base will need to be 5 centimetres. So we can draw a line 5 centimetres long for the base, and then we need another line of 5 centimetres at the top, because with a parallelogram, opposite sides are the same length. And then we can join up these points to finish our parallelogram.